Heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
All right, and hello everyone, students and teachers alike. Welcome back to the virtual classroom series. And if this is your first time logging on and checking us out, I'll just let you know that we first start by pre-recording our virtual classrooms, and then every Tuesday at 11:15 a.m. Eastern Time, we will be on Facebook and Zoom for a live Q&A where you can either chat with myself, Francis Tarazowitz, Weather Observer and Education Specialist, or my fellow Weather Observer and Education Specialist, Alex, if I'm not on that particular week. So this week's topic is going to be pretty interesting. One of my favorite topics in meteorology, and really what got me into the weather, to start, and that is nor'easters. And today we're going to be talking a lot about how they form, what exactly are nor'easters, and more generally, how storms form, those big mid-latitude cyclones, we call them, the ones that give us all that rain, all that snow in the wintertime, those strong winds. We're going to take a nice deep dive into the science. And so without further ado, let's talk about storm formation. So a nor'easter is just a specific type of storm. It forms generally along the eastern United States of North America. And to talk about nor'easters, we need to more generally talk about how big mid-latitude cyclones or big storms form. And so storms, it turns out, are pretty simple. They don't need a whole lot, but what they do need is a large temperature difference, a front, a big difference in air masses, as we've talked about in the past, an upper level disturbance. And all it is a little ripple in the upper part of the atmosphere area of lower pressure that's just moving right along. We call that a trough in meteorology. And that's it. All the storm needs to form is an upper level disturbance and a front. Again, that big temperature difference can lead to a scene like this. This here is the superstorm of 1993, one of the strongest storms on record to impact the northeastern United States. So now we're going to go through each storm ingredient. There's a total of 5 of them. This is part of the Norwegian Cyclone model. And so it states that storms begin as fronts, generally with some cold air to the north and warm air to the south, especially in the northern hemisphere. And so winds along this front are moving in the opposite direction. And so with these different wind directions, rotation may be allowed to start. And so that's where we get to our first stage here. Storm is born. This is the beginning stage. And so if the difference in temperature is strong enough, what's called a frontal wave will actually form. So those winds going in opposite directions actually start to cause some rotation. The cold air starts to move south and the warm air starts to move north. And as that warm air is moving north, it's moving up and over that cold air, forming a warm front. And similar things happen. That cold air is moving underneath the warm air, and that's causing precipitation, a lot of lift and cloud cover. So you can see this little green area here starting to form, starting to get our area of low pressure as well. So let's move right along. Let's advance the storm. Let's start to gain some strength now. This is the intensification phase, and this is when the pressure of the storm begins to lower. And as the pressure gets lower, that pressure difference gets greater, and so those wind speeds, of course, increase. And so wind speeds toward the center of the storm start to increase. You're getting that convergence, you're bringing that air together. And that warm air is going to start to rise even more so over that cold air and create yet more precipitation. At this point, heavy precipitation. We've got what's called a warm sector that's developed. This is where warm air is sort of capped just to the south of the storm with cold air, generally in the northwestern part of the cyclone and the northern hemisphere at least. So we're starting to get that big temperature difference, and it's getting even greater and leading to a lot of different precipitation. When a storm reaches its peak intensity, it's called the mature phase. This is when winds increase even further. The pressure actually bottoms out. It gets to the lowest it could possibly get with the storm. And at the same time, that cold air is starting to catch up to the warm air again. Remember, we talked about storms needing a big temperature difference to actually thrive and strengthen. So this is when that temperature difference starts to wane. That warm sector, that area of warm air is starting to shrink, and the area of cold air is expanding as that storm is dragging more cold air from the north. And so where do we go from here? Well, storm, unfortunately, or fortunately, depending on your perspective. As a meteorologist, of course, we love to see nice strong storms, but anyways, the weakening phase does begin. So what happens is that cold air finally overtakes that warm air. You see, I don't even have a warm sector here anymore. That the cold air is just completely overtaken it. And the front that forms as a result is called an occluded front. That's just when cold air overtakes warm air. So you're left with a really narrow sliver of warm air, but it's surrounded by cold air. And so there's no real temperature difference. And so without that temperature difference, you get less winds, your pressure starts to come up, and your storm starts to fall apart. But what you're seeing here now, how the precipitation is oriented, is called a comma head. And this is usually a sign of a cyclone that's weakening or maybe just started to weaken. You can still see some precipitation, but that big temperature difference is gone, and you're just left with a lot of cold air and breezy conditions as the storm starts to weaken. So with the background and how storms form in mind, let's talk about exactly what is a nor'easter. And as I mentioned before, nor'easters are a storm. They form along the east coast of North America, and they're named nor'easters because the wind is coming from the east. Again, our wind direction is where our winds are coming from. And so with nor'easters, you get a nice, strong northeast wind. And this could cause a whole host of problems. If we're going to talk about, these include high surf, coastal flooding, and things like that. Lots of hazards along the coast. If you're at the beach, of course, you don't want to be in the water with one of these nor'easters nearby. So where do nor'easters form? They generally form between September and May, but they're most common around this time of year, December through April. And so they target the East Coast, Eastern New England, and Canada. And here we have that storm track, most average storm tracks over the last 30 years or so. All these red arrows are showing common storm tracks, but we've highlighted these storm tracks which are off the coast of New England. You can see Connecticut, areas of Long Island, the Mid-Atlantic here. And so those storms, they will form over the ocean and move north and east, and they'll also deliver northeast winds. Nor'easters, of course, like any other big cyclone, they're going to produce a lot of precipitation. And so here's a loop of a particular nor'easter. A few years ago, this was back in 2017, you can see lots of different types of precipitation falling. It's nice heavy yellows and oranges indicating heavy rain, but just inland, you can see those purples indicating sleet. And then, of course, where the colder air is around the nor'easter, plenty of snowfall. Looks like a really good snow dump for this ski country up here in New England. And of course, temperature will determine what type of precipitation is falling from the ground. So in this case, the warm air is to the south. We've got a lot of nice rain, warm air from the ocean being pushed in. And then just inland, you've got a really cold air mass. And so that's changing that rain over to snow, sleet, freezing rain. And generally, the heaviest precipitation with nor'easters is to the northwest of the actual low pressure center, which is located here, and we'll track it along. And so that's why these are such a big deal across New England and the Northeast, because we've got millions and millions of people who live in major cities. So some of the hazards associated with these types of storms, of course, I've mentioned a lot. The high winds can have widespread power outages, especially when nor'easters are occurring in the earlier part of the fall, say October, September, where the leaves are still full on the trees and that wind can just topple those trees down. You can also get a bunch of different precipitation types. Generally heavy, of course, with nor'easters. Rain and snow are the most common, but you can have freezing rain and ice storms as well as those strong winds. And so these are really the big causes of transportation issues as well as school and business closures. You know, nor'easters are great. They give us a snow day once in a while, but they do also cause quite a bit of damage and disruption just to general society in New England. The biggest disruption comes along the coast, with coastal flooding. We've got an image here from Situate, Massachusetts. Those waves pounding up against the seawall, spraying into homes there. That's a very common theme with nor'easters. Again, you have those northeast winds, and it's pushing that water into shore, onshore, I should say, and causing all sorts of headaches, travel, and potentially even home damage. Also causing beach erosion. So your favorite beach may actually be completely altered after a nor'easter passes by. You'll notice a large drop off in the sand as well. So that's just a telltale sign of erosion there. Here's some images. We've got coastal flooding. We've got a poor motorist vehicle stuck in what looks like some slushy frozen seawater. Noreasters also cause a lot of snow. Here we are, feet and feet of snow. This looks like near Boston. And noreasters can bring cold air very far south as they pull away. So here's an image from Savannah, Georgia. The nice mossy trees itself, covered in some snow and ice. So these noreasters primarily affect the Northeast, but they can also have wide-reaching effects around the United States. Just another image of coastal flooding. It looks like a water rescue, unfortunately, ongoing in this picture with a raft and someone wading through the water. Noreasters on Mount Washington. Generally, these are our most extreme storms up here on the summit. It's going to be windier up here. We're more likely to see snow than rain with noreasters, and warm air is very far to the south generally as those noreasters track along the coastline. We'll see upslope snow showers lingering for days and days after the nor'easter pulls away. So what happens is the storm pulls away, you get strong northwesterly winds, and those winds come up and over on the windward side of Mount Washington and actually produce clouds and snow if it's cold enough. And regardless of the track of the storm, the mountains are going to be impacted in some way. I showed you that graphic a few slides ago, and any of those storm tracks is going to affect the mountain here on the summit. So here's an image from a previous nor'easter. Here's an observer braving the wind, flying their tropical storm flag to indicate tropical storm force winds on the summit. I want to talk a little bit now about hurricanes versus nor'easters. There's a lot of confusion, so I want to clear the air a little bit. Similarities between hurricanes and nor'easters: they form in the Atlantic. They're both cyclones. Again, that's counterclockwise spin around an area of low pressure producing precipitation. Now the differences. Nor'easters are fueled by cold air over warm water. Again, those big temperature differences, and they're in this narrow area of the map here that they affect. For hurricanes, they're what you call surface-based. They need that warm air over warm waters to form. The warm air is rising, of course. It's very moist as well, and so it's a rich source of moisture and energy as well. So hurricanes, they need warm water, at least 80-degree water to actually maintain themselves. When nor'easters are not very picky, they just need a temperature difference, and again, that upper air disturbance. Here are a couple of satellite images of hurricanes versus nor'easters. These look, you may hear on the news, oh, we got a wintertime hurricane. Not quite the case, even though this is a really beautiful, well-defined nor'easter. You've got your big cold front in the clouds here. Again, your heaviest precipitation is probably occurring on that northwest side. In the center of the low pressure, it's got a little bit of what looks like an eye. It's not quite an eye. It's not quite the same process. And over here near my shoulder, we've got a classic hurricane. These are nice symmetrical storms. They're pretty round. And again, they're feeding off that warm ocean water. And you can see actually probably what was a nor'easter to the north of this hurricane with its front trailing. And you can see the same sort of feature here at nor'easter. There's the big cold front. And then this larger area of cloudiness is actually the warm front. That's the steadier precipitation as opposed to the heavier but brief precipitation along the warm front, or the cold front, I should say. So some takeaways. I know we went through a lot of material here, but I want to talk a little bit about the takeaways that we can gather from this lesson. Again, storm ingredients, temperature difference, upper level disturbance, two important ingredients, but they're pretty simple storms. And we've got 5 stages to a mid-latitude cyclone. We start with our frontal feature, just that difference of air mass. The beginning phase, those air masses start to move around an area of low pressure, and they start to help to deepen or strengthen the low pressure, drop that pressure even more. That leads us to the intensification phase, where your warm air is cut off in what's called the warm sector, and the cold air is now wrapping around the northern part of the low pressure. The mature phase is when you still have your well-defined warm sector. There's still a temperature difference. The storm is at its strongest. And then finally, all good things or bad things must come to an end. That cold air completely wraps around the cyclone and causes it to dissipate without that temperature difference. And so specifically now about nor'easters. Nor'easters, of course, mean high winds from the northeast. That's where they get their name from. Nor'easters deliver heavy precipitation in the form of snow, sleet, freezing rain. They also bring a lot of high surf with those northeast winds pushing the Atlantic Ocean water closer to the coast and really getting that surf choppy. There's plenty of hazards and impacts as well, We've got inland flooding, we've got coastal flooding and beach erosion. Widespread power outages can also be a big concern with strong winds and, of course, heavy precipitation. And then Noreasters are really known for causing transportation and business delays and closures. So here's a former observer shoveling snow after a nor'easter. You can see at least a foot of snow in this picture, nice and drifted up around the northwest part of the observatory. And so that concludes today's lesson. I just want to point out some resources here. If you're interested in joining us for our Q&A, you join us at mountwashington.org/classroom. There you can register for a Zoom link, which gets you on to joining the program. Of course, you can always submit the questions that you may have for me or fellow observer Alex. You can send them to my email at fterrazowitz@mountwashington.org or education@mountwashington.org. We're just going to briefly visit the site here. Hopefully the link works. There we are. And so, yeah, this is the site where we have previously recorded virtual classrooms. We can see Alex explaining severe thunderstorms, for example, in a previous lesson. This is me talking about wind. And so you can register for live programs by clicking the link. We see the link already here for Noreasters ready to go. And we'll have the live program this upcoming Tuesday, November 29th. And I'd like to thank you all for joining me today. And I look forward to your questions. And I hope everyone has a fantastic day.